The next demonstration we're going to be doing is to show you how to install your earth spikes, exactly where to install your earth spikes and why they need to go where they are. So the first thing we do is we measure 10 meters away from the house, from the mains power supply, as per legislation. 7, 8, 9, 10. The earth spikes will then be positioned 1.2 meters apart from each other. The second one will be 1.2 meters from the previous one over here. And then the third one, exactly the same as the previous two. The earth spikes will then be connected all together in a straight line from the energizer to the fence. As per current legislation, you might be wondering why we always have 3 earth spikes at the energizer and from there on 30 meters. The following demonstration with a earth resistance meter will tell us exactly why. So what we have is our 3 earth probes simulating our 3 earth spikes. We then have our potential probe, the yellow one, and the current probe, the red one. On our digital earth resistance meter, we have a current reading which simulates that our earthing is not that great. Once we move the earth spike further apart from each other, as in our 3 earth spikes, moving them 1.2 meters apart, we take a new reading. As we can see, the new test has a much lower resistance, and as you know, lower resistance equals better conductivity. Okay, so our first demonstration was showing you the importance of having your earth spikes 1.2 meters apart. The next demonstration is going to be about depth. We can see at the moment the probe is not all the way in. The reading we are having over here, the potential is not that great. Once I make the depth better, you can see it's now further in quite a bit. The next reading we will take gives us a far better potential reading.
The SWAN-stack requires a maximum resistance of 300 ohms across your earth system. Gavin in his demonstrations today showed the importance of the spacing of your earth spikes further apart at the 1.2 meter requirement. He also showed the importance of having 3 earth spikes. The more earth spikes, the lower resistance. And secondly, he showed us that the deeper you knock your spike in, the more it improves the resistance in the ground. From adding the spikes to the width apart of 1.2 meters and getting them deep in the ground, we clearly and quickly got the resistance to under 300 ohms. I cannot stress the vital importance of earthing. In my experience, about 60 to 70% of the problems we experience when we go out to sites is related back to earthing. The bigger and more powerful the energizer, the more electrons are going into the ground and the further they're going to go. So the bigger the energizer, the more earth spikes we put in the ground. So often we've seen where farmers just put a single earth spike or installers just put 1 or 2 earth spikes, the electrons into this ground and they travel everywhere. This means that you touch a tennis court fence or you grab a gate and you get the shock off it. This is all due to poor earthing. If you had a decent earth with an under 300 ohm resistance, those electrons would flow directly to the energizer earth and back to the energizer, and you wouldn't be receiving all the induction and shock effects that you get off other things. It also protects the energizer because the energizer circuit board is now properly earthed and there's a clear potential between the negative and the positive, so even the electronics work better and last longer.